go to the how finally you can calculate it and then to report the height of this absorption column. Okay, but before that, you need to know. Okay, why is it not moving? Okay, so in order for you to calculate, okay, like I mentioned, okay, dalam ni ada tak kosong? Side kosong. So it's like this. Okay, dalam IP kat sini lah. Ada kosong sikit. Okay, dalam fixed bed, normally absorption, okay, operation of absorption, we will do it in the fixed bed column. Kalau you pernah dengar fixed bed reactor, back reactor, so it's like that, the setup. Okay, this is column. Okay, this is normally the column. Alright, so you ada outlet lah, and you ada inlet. So what happened inside this column? They put this adsorbent. Okay, this adsorbent is fixed. Okay, you ada juga fluidized bed. Fluidized bed meaning that the adsorbent will be fluidizing. But normally for adsorption, it's going to be like fixed bed. You fix the bed. Okay, you ada bed ni, you akan fix the bed. So macam mana dia boleh fix? So normally dia akan ada like, they put like a mesh. Okay, mesh on the top side and also the bottom side. Okay, they loaded dulu. Okay, what happened? Dia letak bottom dulu, mesh, and then supaya dia tak jatuh ke bawah lah. Okay, untuk to retain it on the top. And then dia akan load adsorbent ni with certain mass. Of course, you dah tahu mass tadi berapa kan? Macam ni nak tahu Q dia maksimum. Berapa kilo you ada. So how do you determine how much mass that you needed? Is basically you kena tahu what is your concentration yang you nak absorb. Okay, so how long you gonna take? So from there you know that okay, you need like 100 kilo for example. Then you kena load lah 100 kilo dalam ni. Lepas dah load, barulah you tak mesh kat atas ni supaya dia tak pergi ke atas. Okay, dia tak pergi ke atas ataupun dia ke bawah. So once you ada ni, then you akan let's say you ada feed yang masuk solution lah. Solution yang ada solute masuk and in contact masuk dalam ni and akan keluar. So bila dia keluar, concentration kat sini katalah tinggi. So dekat yang outlet akan jadi concentration rendah. So dia adalah percentage yang dia akan absorb. Let's say atas ni you akan ada 100 milligram per liter, maybe kat bawah ni you just remain with 1 milligram per liter let's say. Ataupun 0. Okay. Alright, so then our function now, your function is to calculate this. This is what we call it total height. Okay, total height of this bed. How much you need. Alright, so to calculate this one, you need to know important parameters, what we call it mass transfer zone. You need to know this mass transfer zone in order for you to determine your total height, your bed height lah. Kita panggil HT lah, HT. Okay, so this is basically the one that you need to know. This is mass transfer zone yang required. Okay, yang you required this one. So from this data, remember that this data you have to have C over C naught. What is C? C is basically concentration over time. Okay, over time. Macam contoh 1 jam, 2 jam, 3 jam you ambil dia punya concentration. And then C naught is basically initial concentration. So you just divide. Let's say 1 hour, berapa concentration you divide by initial berapa. So you akan dapat ratio. So from this ratio you boleh plot lah. You akan plot, you akan dapat this kind of behavior. Okay, this is what we call it mass transfer zone. So we need to actually know exactly what do you have in this mass transfer profile. Okay, apa yang you ada sebenarnya. Okay, nanti kita akan pergi one by one lah. Okay, but before that, okay, this is to make you understand how this mass transfer zone profile being plot, and then why the data is like that. Okay, kenapa dia kat sini is like this. Alright. Okay, so masa adsorption, during the adsorption process, so let's say you put in your fluid here. Okay, so just imagine this is your total height of your adsorbent. Let's say this is adsorbent bed. Okay, sebenarnya dia macam ni lah. You ada column. So this is your adsorbent bed. This is HT. You punya bed height. Okay, so what happen is that, okay, dalam adsorption, okay, this is, kalau you tengok graf ni adalah solute concentration in bed. Solute concentration in bed maknanya berapa banyak solute yang absorb dalam adsorbent. And this is time. As you have, if you run more time, finally you akan dapat dia punya mass transfer zone tu. Kalau you run sekejap, you takkan dapat dia punya data kat sini. You not be able to reach until that mass transfer. Okay. So before you want to reach that, okay, you have to understand, okay, dalam kat sini, dalam adsorption, in adsorption, first thing, bila first fluid coming in, okay, dia akan keluar, right? Dia akan keluar. So what happen is that, just imagine in this total bed, you can divide it into a few sections. You have to imagine that. Let's say you divide it into few sections. Section 1, section 2, section 3, section 4. So you ada H1, section 1, H2, section 2, H3, section 3, H4 is the last section. Just imagine, you can divide it into few sections. Memang you tak boleh divide pun, tapi you just imagine, you have that kind of section. So with this total mass yang ada dekat section 1 ni, what happen is that, all the solute yang you ada dalam fluid, dia akan being absorbed. Semua akan absorb. So what happen kalau semua absorb? Katalah yang masuk ni C in is 100 mg per liter. So semua being absorbed at first zone. Dia tak sempat pun pergi second zone. So dia akan lalu lah. Liquid tu akan lalu. H2, H3, H4. So what happen kat sini? Concentration you akan dapat zero. Pasal the outlet will be zero. Always zero. Because everything is absorbed by the section 1. Okay. And then the section 1 will reach saturated. You dah tahu kan saturated kan? What is the saturated condition? So all the adsorbent absorb the adsorbate or solute. So sampai dia reach saturated. There's no pores anymore that can be absorbed. So what happened? You still feed in, okay, the column yang sama ni, you still feed in, betul tak? You akan feed in fluid tu continuously. So the adsorption zone akan tukar daripada H2, dia akan pergi kepada H1, dia akan shift kepada section 2 pula. So dia akan shift kat section 2 sini. So section 2 ni akan buat adsorption juga sampailah dia saturated. And then what happen? C out you masih lagi kosong. So that's why kalau you tengok time base ni, concentration dia sentiasa zero. Pasal apa? Dia only di specific zone yang buat adsorption. And then you feed in lagi, sama juga, you feed in more, and then they pass over to the third section. Alright? So now the third section, and then dia keluar lah. Dia keluar. So concentration you masih lagi zero that time. C masih lagi zero. So dia pergi kat third section. So third section akan buat adsorption. So maknanya section 1, section 2, section 3 semua dah resaturated. Okay, everything dah resaturated. Okay, but the good thing is your outlet still zero. Right? And now you feed in, okay, you feed in, you know that the section 1, section 2, section 3 semua saturated. So now they move to the last section. This last section, section 4. Okay. What happened? Saya punya slide tiba-tiba hilang. Dia close. Kita tak nampak slide kan? Betul tak?
Tak nampak.
Tak ada slide tak? Tak. Dia tiba-tiba dia close. Alright. Dia ada problem sikit. Saya buka balik saya punya PowerPoint. Okey, dah keluar balik. Okey. Okey, nampak dah balik slide.
Nampak Doktor.
Okey.
Doktor.
Thank you. Alright. So, okay, tadi kita dah ada saturated bed yang mana you ada zone 1, zone 2, zone 3. Now they move to zone 4. So, masa ni zone 3, you still have 0, C up is still 0. Kosong kan? Okay, now they move. Okay, you still fit in because the absorption going to be happen continuously. So what happen, this last zone pula, dia akan start saturated. Okay, bila dia start saturated, so your outlet kat sini akan start increasing from 0. Okay, from 0 dia akan naik lah C kepada 10, 20 until C outlet equal to C inlet. So you akan dapat lah data dia kat sini, dia akan start naik. Okay, because of what? Because yang atas ni semua dah saturated. Okay, so what happen? Fluid ni dia akan just pass through je the saturated zone. And then they move to the last section. Last section ni, dia akan start to saturated. Dia akan start reaching saturated. Meaning that the concentration outlet akan start increasing. So bila you plot, dia akan jadi macam ni lah. Dia akan jadi like this pattern. And then bila you draw, dia akan dapat like this. So this is this level kat atas sekali adalah C outlet equal to C inlet. Let's say you punya inlet is 100 mg per liter. So when everything already saturated, so meaning that your punya C outlet will be the same as C inlet, 100 mg per liter juga. Okay, so this is the mass transfer zone yang you akan obtain bila everything is saturated. Alright. So in practical, normally you will not use absorption until you reach C in equal to C out. Of course, you will not accept it. Because of what? Because normally adsorption ni maybe it's like a polishing process, the final process and so on, ataupun purification process of your stream. So what happened? Let's say you want to have like C inlet ni 100 milligram per liter. So when you put in the adsorption, maybe you want to have your outlet going to be like specification maybe less than, let's say less than 5 milligram per liter. That is the acceptable outlet yang you will accept. Kalau if they are more than 5 milligram, then you cannot accept that outlet. Okay, that stream yang outlet tu you tak boleh accept bila dia more than 5. So what happen? Normally you akan stop the adsorption before they reach 5, right? Okay, of course before it not reach the same as the inlet. So kalau you nak stop before 5 ni, of course you akan stop kat mana? You akan stop somewhere here, right? So in fact you punya total height ni, you still ada area yang boleh absorb, but you don't want to use that area, because if you use that area, the mass, the concentration start to increase, exceeding your punya specification. Okay, normally you ada specification you lah, you cannot exceed this value. Okay, so considering that, so the total height here is basically combination between this H. Okay, this H you ada 3 zone tadi kan? Example you ada 3 zone, H1, H2, H3. So this H, the 3 zone kita panggil HB. What is HB? The height that being used. Okay, the height that saturated. Okay, the one that already saturated. And then you left with a section that are not saturated. Kalau you biar dia saturated, you akan get the outlet equal to inlet. You don't want it. And even it's not meeting the specification. So this section bawah ni kita panggil HUNB. HUNB is what? Unusable punya section. Yang you tak use pun. Okay? Tapi dalam calculation of H total is basically is between HB plus HUNB. Okay, you kena tahulah ni. Okay, untuk dapat total height is basically H yang being used plus dengan H yang unutilized, yang tak digunakan. Kalau you guna, you akan dapat saturated. You akan reach concentration yang exceeding you punya specification. Let's say your specification is 5. Okay, faham tak? I hope that you understand this concept. Because once you understand it, then you know that, oh, why we find the HB dulu, lepas tu dapat HUNB, and then later on you dapat HT. Okay, so there's a reason behind it. Okay. Macam dia keep this last section as a safer punya zone lah, safety zone. If you use it, you're gonna reach saturated. You punya outlet will not comply with any requirement or product specification that you want. Alright, so the one that you put as your punya specification, let's say 5 mg per liter ni, is basically we call it break point punya point. Okay, how to get the break point? Break point is basically the C set outlet, you set dekat outlet tu berapa, divide by C inlet. Let's say you punya C inlet is 100, your set point is 5. So this break point is going to be 5 divided by 100. So it's equal to 0.05 lah. So this point, because you know that this one is ratio C over C naught. Okay, so you plot that one. So this is we consider as break point. It's very important to determine where is your break point. Because of what? Because it's gonna make your life easier later on to make a calculation to find the HT, HB and HUNB. Okay, kalau you tak determine the break point, your life gonna be miserable. Okay, until now you can get it? The concept? Ada question? Tak ada. Okay, once you get that concept, now is the time to do the calculation. Okay, so this is where you will know that the equation, capacity of column and scale up design method. So kalau you nak scale up macam mana? Let's say you buat eksperimen dalam lab scale kecil je, and then later on you want to scale up to bigger one. So it's for adsorption, it's very easy to scale up. It's like direct scaling up conceptnya. Okay, remember you dah ada transfer zone ni tadi. You ada mass transfer, you ada C over C naught. Okay, kalau kata let's say you punya data, let's say they give you data is only C. So what happen? You kena dividekan C over C naught. Baru you boleh plot this one. Right? Kalau you tak divide, you tak boleh plot this one. Because this is ratio. Dia panggil time equivalent. Okay, dia tak ada unit. Okay, this is dimensionless. There's no unit. So that's why it's a ratio. Okay. So here, remember that you are a CB. Okay, CB is what? The breakpoint. Yang you kena determine tadi. It depending on the specification ke, what is the outlet that's supposed to be. You cannot exceed certain limit. So that is the keyword that you can determine your breakpoint, because normally dalam soalan in question they normally not mention clearly this is CB. No, they will say like the limit. They will say that this is need to be compliant to this concentration. So that is understood the keyword to find the CB, because CB is going to be like concentration that breakpoint divided by C naught lah, C initial. So concentration at set point or limit you want to set. Kita dapat CB. Okay. So here you need to find the total height. Okay, before you can find this one. You know why? Because this is the HT. The one I mentioned, HT equal to H unusable plus HB, the bit that been used. So to find the H, U and B, you need to know this one. 1 minus TU over TT over H times HT, and HB is TU over TT HT. So you need to know what is the TU and TT. What is TU and TT? Okay, TT is basically what we call it time equivalent to the total capacity. Okay, time equivalent to the total capacity is basically the whole thing here is TT. Okay, area that above the curve, mass transfer zone. So this is the area that we want to find. Okay, you can use your numerical method if you expert on it. Alright, to find, because under the curve you need to use like Simpson method and so on lah. Alright, but in this particular case, later on I will teach you the simplest way. Okay, sebab tu nak kena tahu where is your CB. Okay, kita boleh pakai those method. And then another one is TU. What is TU? Is the usable capacity of the bed up to the break point. Maknanya time of equivalent until your break point. Kat sini. Kat sini sampai sini adalah TU. Alright. Is integration of 0 sampai TB 1 minus C naught divide C over C naught dt. Okay, so this is basically equal to area. So this is also equal to area. Area of what? Okay, I show you what is the area. So tadi ada CB kat sini. So basically you can divide this thing into two part. Okay, the simplest way is this is two part. This is, I call it area A1. Okay. And then you have another part here, area A2, the one that above the curve here. So this is A2. So TT is basically the whole things here. Okay, this is TT. So it's basically equal to area A1 plus area A2. Okay, for TU is equal to area of area 1, because this is for TU pasal until breakpoint. So it's equivalent to that area. So if you able to find the area, then it's equal to this integration. No need to find the integration, just find the area. So to find the area here, okay, listen carefully how to find the area. Remember that you have the area A1 here. So this is area A1. You just slide it like this until CB here. So you still have like unshaded one, but just ignore it, assuming that this is rectangle. Okay. Kalau rectangle macam mana dapat area? You tahu dia punya height here. You tahu dia punya width here. Dan you kali lah. W kali H. You dapat area A1. So height dia adalah 1. Sebab tu dia pakai ratio 1.0. Kalau kata you ada graph, sometimes ada question yang bagi you macam gini, tapi sini tak sampai 1, mungkin this is 0.3. So By all means, if 0.3, then you know that the height is going to be 0.3 lah. Ikut follow je kat sini. 0.3, but make sure that this is ratio. C over C0. Make sure that is ratio. Kalau bukan ratio, tak boleh. Okay, so this is height is 1.0. So width ni berapa? So width ni you kena cari lah. 0 sampai TB. TB di berapa nilai dia? Let's say TB ni 6 hours. So kali je lah. 6 kali 6. So you get 6 equal to area A1. Boleh? Untuk TU. Ada soalan? Tak ada. Alright. So you dapat area A1. So now you want to find the area A2. So you know that this is TT is area A1 plus area A2. So now you want to find area A2. So A2 sini, how to find it? Okay, it's very easy. Method ni boleh guna untuk adsorption saja. Jangan guna untuk subjek lain. So what happened? Okay, this is the area that you want to find. Okay. So you need to know the middle point. Please find the middle point of this curve line. Ataupun middle point dekat sini lah. Dekat height ni. Kalau dia 1, middle point adalah 0.5. So this is middle point. And then you plot dia dekat sini. Dekat graph ni. So go down. So go down, you know that as a TS here. Okay, TS. So what happened next? Okay, saya kena delete dulu supaya you boleh. So you dah dapat TS ni as a TS here. So what happened? You draw line sampai atas sini. So this is now you get another rectangle. So this rectangle is basically the one that you need to find the area. So just imagine that this rectangle is symmetry dengan area sini. Area sini adalah shaded kan, tapi you tak cover, tapi this one is unshaded. So this unshaded, kalau you gunting, if you cut it and then you paste it here, it's basically it's more or less the same, the area. So that's why you find this rectangle. Okay, so nak macam mana dapat rectangle? Dapatkan dia punya height ni. What is the height here? Alright, let's say kalau satu lah 1.0. And what is the width here? So the width here is basically TS minus TB lah. This is TS, this is TB. You minus kan you dapat lah different kat sini. So what you get is area A2. So area A2 plus area A1. So area A2 is height times dengan TS minus TB lah. Ni you punya W. Alright. And then you pluskan dengan area A1. So you dapatlah T, TT dan juga TU tadi dapatlah area A1. Okay, boleh? Okay, understand? Question? No question. Right. Assuming that you understand, even you pretend that you understand, that one I cannot. Is beyond my control. So the one that get clever is you, not me. Alright, so once you already know how to, you already find the TU and TT. So now it's very easy to use in this equation. Alright. To find the HB, so HB equal to TU divided by TT times dengan HT. Okay, kebanyakan dalam equation ni, if you look in this equation, you already know what is your HT, what is the total height. And then you fix what is your total height. And then now you want to know what is your zone of HU and B and what is your zone of HB. Alright. So to conduct this experiment, but it's typically when you have your bed, you just try to have your bed at certain height. Biasanya you akan try dulu because this is try error, and later on you will recalculate. Okay, when you recalculate that you know that, oh, exactly the HB is going to be what value, HU and B is what value. Then from there you will do the scaling up. Okay, that is easiest way lah normally. Okay, bila you run dalam small scale. So that's why kat sini banyakkan equation you dah ada HT, you dah fix HT katalah I nak 2 meters. So you buatlah 2 meters. From 2 meters, then you later on you will reverse to calculate what is your HP and what is your HU and B. Then finally you will do your scaling up to have like 20 meters punya column pula. Okay, so this is equivalent to HTU dengan TT is area A1 divided by TT is area A1 plus area A2 times dengan total height. So this is how you want to find the bed used up to break point. And unused bed HU and B is basically 1 minus TU divided by TT area A1 divided by T1 plus A2 times dengan HT, ataupun this is also equivalent to the HU and B is equivalent to T minus TU lah, alright, divided by TT, ataupun area A1 plus A2 minus A1 divided by A1 plus A2 times dengan total height. Alright. Ataupun you dapat ratio ni, katalah ratio ni is equal to 0.7. So this one gonna be 0.3 lah. Ratio kat sini 0.3 times HT. Pasal kalau you buat bed height ni, total is 1.0 the ratio. So kalau you ambil 0.7 is HB, so this part gonna be 0.3. Okay, another way lah. Ataupun you masuk je lah 1 minus area A1 divided by area A1 plus A2 everything times dengan HT. So you get HU and B. Alright. So once you get the in this case that you don't know the total height, you find the HU and B plus dengan HB, you get the total height. Okay. Past exercise dalam you punya I think worksheet, okay, you can find it in the column. So let's say you ada ni, you ada time, you ada concentration, you ada time. Okay, so this is they only give you the concentration. Okay, they give you like time, concentration. So you know that you need to plot what? C over C naught time T. So you need to do C over C naught lah. What is a C naught? Okay, read through this question. So you have like water vapor was removed from nitrogen. So you want to remove water vapor from nitrogen. Okay, dalam gas stream. Guna back column. So the column height, dia dah bagi 0.5. Column height dia 0.5. HT is equal to 0.5 meter. With the bulk density of the bed is 750 kg per meter cube. The initial water concentration, okay, dalam solid ni, dalam absorbent U ni ada water 0.01 kilo water per kilo solid, and mass velocity of the nitrogen gas was, okay, ini dalam bed ni you put in nitrogen gas, so dia punya mass velocity is 4052 kilo per meter square hour. So the initial water concentration in the gas was, the initial yang masuk adalah 930 times 10 minus 6 kilo water per kilo nitrogen. So the breakthrough data dia bagi tadi table. So determine the break point, the fraction of total capacity of break point, the length of unused bed, and the saturation loading of the absorbent if the allowable outlet concentration is set to this one. Allowable outlet concentration, maknanya kat sini you nak dapatkan CB. CB gonna be like 2 times 10 minus 5 divided by initial what? 930 times 10 minus power 6. Okay, so this is your CB. Dia tak bagi tahu exactly what is the CB punya value, but they talk about the allowable outlet concentration. So this is going to be your CB. Okay, the second one, if the column height is increased to 0.8 meter. Ni katalah tadi daripada 0.5, now they increase to 0.8. What is the break point and the fraction of total capacity used? Apa nilai yang baru? Okay. So sebelum you nak solve benda ni, kita tengok example yang dalam buku teks. Okay. Yang ini you boleh buat lah macam ni. Lepas tu nanti you plot, you akan dapat like something like this. Okay. And then you find lah dia punya area A1, dia punya area 2. So you dapat lah TU over TT. Sama juga macam yang example ni. You tengok example ni, nanti you boleh buat that exercise. But that exercise normally you already try it at home. Okay, so here we discuss generally how to solve it. And kalau you ada problem, you ask question. Not that I will solve it one by one, how to solve it. No, I will not do that. Okay, it's going to consume a lot of time. So that's why it's advisable you do it first. Alright, try at home. Problem, raise up here. Alright. Kalau you tak buat, I already asked you to do it, but you don't do it. I cannot push you. Okay. So the one that want to learn more is you, not me. Okay, let's say kita tengok example ni. Ni yang simple one dalam you punya textbook. So you ada alcohol vapor dalam air. So meaning that you want to absorb the alcohol. Okay, guna activated carbon. So the diameter of the packed bed is 4 cm and the length of the bed is 14. Okay, length of the bed is 14. So maknanya you ada total height is 14. Dia dah beritahu. Adsorbent you ada 79.2 gram. So kalau you draw it, if you're able to draw it, so the height here is basically 14 centimeter, and the activated carbon here in terms of mass that you masuk is 79.2 gram of carbon, activated carbon lah. So you feed in, dalam ni you nak absorb what? Alcohol. Okay, so the inlet stream having concentration, you see not 600 ppm. Okay, and density dia bagi 0.0115. Enter the bed at the flow rate. So dia bagi flow rate. Flow rate is 754. So the data table give the concentration of the breakthrough curve. The breakpoint concentration is set at this one. Dia bagi dah. Dia bagi tahu you breakpoint is C over C naught is 0.01. So it's easy for you. Kebanyakannya tak bagi. Okay. Please remember that most of them is not given. So do as follow. Determine the breakpoint. Mula kena buat breakpoint. CB. Determine the breakpoint time. Okay, bukan breakpoint value but time. Time dia kat mana? Dia punya time dia. Ada paragraph nanti. The fraction of total capacity used up to the breakpoint. This is TU divided by TT lah, fraction. And the length of the unused bed, H, U and B. Okay, also determine the saturation loading capacity. The saturation loading capacity meaning that the Q. So how much the adsorbate or the alcohol being absorbed in 79.2 gram of carbon. Berapa banyak yang boleh absorb by 79.2 gram of activated carbon. Okay, the second one, if the breakpoint time required for new column is 6 hours. Okay, kalau katalah breakpoint tu dia extend kepada 6 hours. What is the new total length of the column height? Okay, no, new total length maknanya new HT new lah. Berapa yang baru? Tadi 14. Sekarang ni berapa yang kena naik? Okay, this is dibagilah breakthrough concentration time over C naught. Dia dah bagi C over C naught. So mudah juga untuk you. You just plot it. So dia dah plot macam ni. So this is C over C naught. Kalau dia bukan C over C naught, you sukar lah. Not necessarily, sometimes it's until 1. Kadang-kadang dia sampai curve ni dia sampai maybe sampai you akan jumpa juga soalan-soalan yang bila you plot it's like kat sini. So this one is maximum is 0.4, let's say. Well, it's okay, you just plot it. Okay, as long as this one is C over C naught. Okay, now you determine the CB. Okay, 0.01. Dari sini 0.01. So you pergi bawah ni, ini adalah dia punya TB yang diminta tadi. TB berapa ni? 3.7 hours. Okay, so that is the answer lah for that one. Once you determine the CB, remember that you can divide it into two area, area A1, area A2. Alright? So macam mana dapat area A1? Yang ni kali dengan ni lah. Okay, yang ni adalah 3.7 kali dengan 1.0. So you dapatlah area A1. Area A2, dari point kat sini, point 5. So daripada point 5 ni pergi bawah ni, you dapat TS. Okay. TS ni you dapat this rectangle. So whereby height dia 1.0 kali dengan kat sini, berapa dia punya width dia adalah TS minus T. So you dapatlah area A2. Boleh So you dapat area A1, A2, you can get TT. Tambah je lah dua-dua ni. Okay. So do not find, ada orang buat kesilapan ni. There's a student that do a mistake. Okay, diingatkan TT itu adalah sampai sini. So bila dia tengok kat sini, when they see that the last point here, when they look the last point, alamak, last point ni apa? 6, 7. Can someone, because I punya ni tak moving slide. What is the last point? Kat sini 7.0 eh?
6.8.
7.8. Saya tak nampak because my slide not moving. Okay, sini. Sorry, 6.8 let's say. Okay, ataupun dia extendkan sikit tu dia dapat 7.0. Okay, do not simply take okay, this one is you punya TT. TT you ingat width dia ni adalah 7.0 kali dengan height dia 1.0. So you akan dapat area untuk TT adalah 7.0. So this is wrong. This is wrong. Basically kita nak dapatkan area above the curve, yang shaded sahaja. So kalau you buat macam tu, you akan dapat juga yang non-shaded ni. So tu adalah salah. Okay? Because ada student yang buat macam tu. So I share when I do marking. I don't know why they do like that. Okay? So you dah dapat this one. So you dapat TT. You see that kalau you buat semua, you akan dapat 7.0. But when you calculate correctly above the curve, you just get 5.16 here. You nampak kan? Beza kan? So that is make different. You thought that you get the marks for working, but there's no working because the answer is wrong. So the working also wrong, so it's 0 marks. Very simple. So TU is area A1. So area A1 is 3.65. Okay. To get the ratio of TU over TT until breakpoint, so you bagi je lah 3.65 divided by 5.16, you get 0.707. Okay. Unusable is 1 minus TU over TT. So TU over TT is 0.707 minus 1 times dengan height dia bagi 14. So HUNB is, the answer is 4.1 centimeter. So maknanya you can imagine that this is your column tadi. Okay. Total height is 14. Okay. So bila you calculate, the HUNB is only 4.1. So maknanya yang bawah ni 4.1 is basically this one, HUNB. HB berapa? HB yang sini. HB gonna be 4.1 minus 14 lah. You akan dapat 9.9 lah, lebih kurang. Okay, bila campur dua ni, you akan dapat 14. So this is how you can determine where is that zone, HB and HUNB. Okay, bila dapat tu, okay, now dia cakap apa? Okay, kita tak pergi saturation lagi. Dia ada satu soalan kat sini, saturation loading, nak terdapat Q. Kejap lagi kita pergilah, kita pergi B dulu. Okay, yang the B punya question, let's say the TB dia extend sampai 6 jam. Remember that, yang first one, TBU kat mana? TBU adalah dekat 3.65. Okay, TBU. Okay. First TB adalah 3.65. Now, The new column, they want you to calculate the new column provided that the new TB new, I put new, is extend to 6 hours. Okay, extend to 6 hours. So kalau you tengok balik, okay, macam mana you nak faham benda ni, how you want to solve it, to tackle this problem, it's very simple sebenarnya. Kalau you tengok balik graph mass transfer zone, C over C naught, dengan T kat sini, tadi TB kat sini adalah 3.65 kat sini, and then dia start naik, right? Macam ni, betul tak? 3.65, this is you punya CB first. Now they extend the TB to 6. Katalah this is 6. So what happen? This curve akan shift kepada sini. So you akan dapat satu lagi curve, U curve, C over C naught. This is T, this is 6. So curve you akan start kat sini pula. So you shift, you just imagine this curve, you shift kepada sini, so dia akan jadi kat sini. So there is no curve here anymore. You nampak tak apa berlaku? So bila you shift macam tu, so kalau kata you nak cari dia punya area, very easy kan? You nampak kan? Sekarang dah jadi macam ni. Tadi dekat sini, dia start dekat sini, curve ni dekat 3.65. Sekarang ni TB baru adalah dekat 6 jam. So what happen? Mass transfer zone sama. Please remember, if it involve the same solute, the same adsorbent, the mass transfer zone yang you dapat curve ni adalah sama, dia punya profile dia, pattern dia, tak berubah. Unless you change dia punya solute, bukannya alkohol lagi, mungkin dia dah jadi something else. Dan juga adsorbent you tak pakai atom carbon, mungkin you pakai alumina, dan tak sama lah, dia akan jadi tak sama, tak boleh buat macam ni. Okay, ini case yang sama. So what happen kalau you nak calculate punya area, you tahu this is area A1, this is going to be area A2 kan, betul tak? So yang berubah adalah mana? Area A1, dia akan jadi extend lah, panjang sikit. Okay, kalau you tengok sini. Tapi area A2 ni, dia sama tak dengan case yang mula-mula? Kalau you if in your opinion lah, you tengok curve dia sama. So kalau you buat kat sini 0.5 pun, you cari area A2 masih sama. Ni area A2 berapa tadi? Ni 1.15. Dia akan kekal sama area dia. Cuma area A1 dia akan berubah. Maksudnya kat sini, kalau you nak cari HT, you nak cari TT, so you akan ada A1 plus dengan A2. So A2 akan sama, A1 akan berubah. Sebab dia dah panjang lah. Bila dia panjang, area dia makin besar lah. Alright? So this is the ideas. If you see this one, okay, now you know that area A2 tak perlu cari dah. Okay, you tak perlu draw pun. Okay, untuk imagine benda ni. No need to draw. Because you know that the area A2 will remain the same. So what happened? Area A2 the same. The height here, 4.1 will be the same. Will remain the same. HUNB akan remain the same even you increase the column height, the total column height. Okay, yang HUNB punya zone adalah sama. Dia akan tetap sama. So what happen? You boleh buat ratio punya ni lah. Ratio punya cara. Kalau you tak nak draw, you boleh buat ratio. Whereby macam ni nak buat, you tahu that HB yang sebelum ni, HB sebelum ni adalah 9.9 cm. Dia punya TB adalah 3.65. Okay, this is yang first case. Second case, you tak tahu HB new, pasal you nak cari. Tapi you tahu TB new adalah 6 jam, 6 hours. So you boleh buat ratio lah. You boleh buat HB over TB equal to HB new divided by TB new. Okay, HB yang lama adalah 9.9, TB lama adalah 3.65. HB new you tak tahu, you want to find it. TB new adalah 6 jam. From there you can get the HB new. So this is the simplify lah. So you akan dapat 16.3 cm. So now from 9.9, the column, the bed now become the HB punya zone adalah 16.3. Nak dapatkan total, you kena tahu HUNB. You know that HUNB punya area remain the same, adalah 4.1. So you just add on, you akan dapat HT is equal to 20.4. So dia dapat kat sini lah. Finally. Okay, this is how kalau you buat longer punya column, berapa you nak kira yang baru. So this is how lah you want to solve it. Okay, saya tahu you all tak ada soalan. Mungkin baru nak digest. So try to do revision. Next week ada problem, come back to me untuk discuss. Alright. So okay, now kita move on kepada saturation capacity. Okay, remember that saturation capacity is Q. Okay, macam mana nak buat? Okay, saturation capacity ni dia tak ada specific equation. There is no specific equation. It depends totally on the data that given. Okay, but finally you need to find Q. What is a Q? Is kalau dalam case ni adalah gram lah, dia bagi gram. Gram of solute over gram of activated carbon. Okay, activated carbon dia bagi 79.2 activated carbon. It's okay lah. So you tahu Q equal to gram of solute. You kena tahulah what is the mass of solute being putting into the adsorption column. Berapa banyak dia putting into adsorption column over 79.2 activated carbon, because this one dah tahu dah, dia dah bagi activated carbon punya mass, dia dah bagi. So now your problem is to find the mass of solute. So how to find the mass of solute? Okay, dia bagi air flow rate. Okay, daripada air flow rate ni you tahu 754 cm3 per second, and then dia bagi you density gram per centimeter cube. Kalau you kalikan dia, you akan cancel out, you akan dapat gram air per hour. So dalam air tu you akan ada alcohol. Okay, so air yang supply, okay, this is kalau nak averaging column tu, air yang supply sebanyak 3122 gram of air per hour. Alright, so dalam 3122 gram of air ni, berapa banyak alcohol you ada? Macam mana nak cari? Alright, so you tahu dalam alcohol, dalam air tu you ada 600 ppm. 600 ppm meaning that 600 gram alcohol per 1 million. So 600 gram per 10 power 6 gram of air lah. So you timeskan dengan mass flow rate of air here, and then you timeskan berapa lama you gonna spend. So berapa lama, how long you spend is basically dekat TT tadi, total time equivalent 5.16 hours kat sini. Dekat TT. So this is how long it spent in the column. So times dengan 5.16 dengan dia punya mass flow rate. So if you cancel out the unit, you get an hour is cancelled, then you get mass of alcohol that being supplied to the column. So mass is about 9.67 gram of alcohol. So you dah dapat lah berapa total mass yang supply. So saturation capacity 6.97 gram bahagi dengan 79.2 kilo of carbon lah. So you get 0.122 gram alcohol per gram carbon. Okay, this is your punya saturation capacity. Okay, kalau kata ada juga example lain ataupun dalam test dia bagi data lain. So whatever data that they give you, try to manipulate all the data finally to get mass of solute dengan mass of adsorbent, then you bagikan dua, you dapat Q. So this is how you want to solve it, because there is no specific equation to solve that. Okay, alright, I believe that you don't have any question, so I think we end up until that. Okay, because it's almost 12. Okay, next week we're going to continue a little bit on the type of equipment, and then a little bit on the ion exchange. Okay, the concept of ion exchange before we move on to the crystallization. Okay, so kalau tak ada soalan, kita akan stop our lesson today at this point. So with that, I thank you very much and happy weekend, everyone. All right.
Thank you, Doctor.
Bye bye.
Thank you, Doctor. Thank you, Doctor.